Now we will see binomial theorem. Binomial means the polynomial which are having two terms. For example, you can see that x plus a. You will find this is x plus a to the power 1. You can write this way, x plus a to the power 1. That means it is, you can write this as x plus a x to the power 0 here. So the one power is there, so you will find the two terms. If you write x plus a square, and if you expand it, it will be x square plus 2ax plus a square. If you count it, these are the three terms, 1, 2, 3. So if the power is 2, 3 terms will be there, and x plus a cube, you will find x cube plus 3ax square plus 3a square x plus a cube. And how many terms are there? That is 1, 2, 3, 4. So what you find, whenever the exponents are n, if the exponents are n, so you will find n plus 1 term. That means if 1 power is there, 2 terms, 2 power is there, 3 terms, 3 power is there, 4 terms. So the terms will be 1 more than the exponent contained by the binomial. Okay. One more important thing you can watch here is the sum of the power in each term. Here you can see that x to the power 1, a to the power 1, because x plus a to the power 1 is there. Here you can see x to the power 2, here a to the power 1 and x to the power 1. 1 plus 1 is 2, and here a to the power 2. So in each and every term, the sum of the power will be 2. The sum of the power of x and a will be 2. Here you will see x to the power 3, then a to the power 1 and x to the power 2. 2 plus 1 is 3. A to the power 2, x to the power 1. 2 plus 1 is 3. Here a to the power 3. So here also you will find in each and every term the sum of the power is 3, because here also you will find x plus a to the power 3. Okay. So in this way you will see that similarly for x plus a to the power n, the total number of terms are n plus 1 term. The sum of the power of x and a is always n. Okay. So this way you will see the binomial theorem. So what you will find in the binomial theorem, this is the expansion will be x plus a to the power n. It is nc0 x to the power n plus nc1 x to the power n minus 1 a plus nc2 x to the power n minus 2 a square plus and so on till ncn x to the power 0 a to the power n. What is nc0, nc1? What is the meaning of this? This is from the combination, permutation and combination. One chapter is there in the maths. So from that part it is NCR. NCR means factorial n upon factorial r factorial n minus r. What is the meaning of factorial n? Factorial n is n minus 1, n minus 2 multiplied with 3, 2, 1. That means if we start from n and if we take one less term in each and every expansions, that means the multiplication of one less term. That means if you see factorial 4, so factorial 4 can be written as 4 into 3 into 2 into 1. Factorial 5, that means it is 5 into 4 into 3 into 2 into 1. Factorial 5 we can write as 5 multiplied by factorial 4. We can write this way also, 5 multiplied by 4 into factorial 3. So the meaning of factorial is this way. Okay. Factorial r can be r minus 1, r minus 2, multiply by 3 to 1. Okay, so this way multiply by 3 into 2 into 1. This way we can represent the factorial n minus r factorial, that means n minus r, n minus multiply with n minus r minus 1 into n minus r minus 2 and so on into 3 into 2 into 1. So the meaning of NC0 is what? Factorial n upon factorial 0 n minus 0 factorial here. Factorial n and this n minus 0, this will be cancelled out because n minus 0 factorial is also n factorial. This will be cancelled out and factorial 0 is equal to 1. The derivation part is not there of the factorial 0. If you see in if you have taken maths, you will learn this in maths, but here you learn this only factorial 0. The value of factorial 0 is 1, so the whole quantity will become 1 here. NC1, this is factorial n upon factorial 1 factorial n minus 1 here equal to, you will see that factorial n we will write as n factorial n minus 1. 1 is 1 only, factorial 1 is 1, and n minus 1 factorial, so n minus 1 n minus 1 factorial will be cancelled and will remain here. So this way we will proceed. NCn is what? Factorial n upon factorial n minus n, so this will be 0. The factorial 0 is 1 here and n will be cancelled, so the value will come 1 here. Now you will see that this expansion, this binomial theorem or the binomial expansion, if x is less than 1, if x is less than 1, then it will be 1 plus x to the power n. It will be written as 1 plus nx plus n minus 1 upon 2 factorial 2 x square and so on till infinite term. Okay, so if x is very less than 1, very much less than 1, so in that we'll omit all the parts, only we are taking the two terms. We are taking only first two terms here. So the expansion would be what? The expansion are significant only for two terms here, that is if 1 plus x to the power n is there and x is very much less than 1, so it will be written as 1 plus nx. This n, the exponent here n, will multiply it with the second term nx. Here 1 plus x to the power minus n, so this minus n will multiply it with x, it will become 1 minus nx. 1 minus x to the power n, so n will multiply it with minus x, it will become 1 minus nx. 1 minus x to the power minus n, so it will become 1 plus minus n is multiplied with minus x, so 1 plus nx here. So you have to remember this thing only. We will use in physics these terms only. Okay, so what means whatever we have read yet about the binomial theorem, no need to learn that thing. Only for the physics you have to learn this 4 formula, and we are applying this 4 formula. Okay, we'll see one question here, that is 1001 to the power 1 upon 4. You have to calculate the value up to 5 place of decimal. You can write this 1000, sorry, it is 10,001. 10,001. Okay, so if you write it, it is 10,000 plus 1 to the power 1 upon 4. 10,000 if you will take common here, it is 1 plus 1 upon 10,000. So 10,000 we can write as 10 to the power 4 into 1 upon 4. 4 would be cancelled here, the exponent, so it will be 10. And as you know here, this quantity, the second term is very less than the 1, so simply 1 upon 4 we will multiply in the second term, so it will come 0.000025, and if you add it and multiply it, you will get this. So up to 5 places of decimal you will get this answer, 10.00025. Here one more question is there, 9,999. 1 upon 3, the power is 1 upon 3. We can write this as 1000 minus 1 upon 3. So it will be what? 1000 we are taking common here, so it is 1 minus 1 upon 1000 to the power 1 upon 3. 1000 to the power 1 upon 3 will be 10, and here the same thing we are doing. The 1 upon 3, this exponent will multiply it with second term, so it will be 1 minus 1 upon 3 into 1 upon 1000. It is 10. 1 minus, this is 0.000333, recurring it would be. So 10, this if you take the subtraction of this or difference of this, it will come 0.999666. this is recurring, so you will get 9.9967 up to the 4 places of decimal. In mathematical tools, now you will see graph, straight line graph. You know that for the linear polynomial always you will obtain a straight line graph, or the two physical quantities which are in direct proportion, for that two physical quantities also you will get a straight line graph. So here the straight line, the formula for the straight line y equal to mx, this is this first type of straight line graph, in which you will see the straight line is passing through the origin. That means y is directly proportional to x. The second formula is y equal to mx plus c. This is also linear equation. So a straight line obtained in this way just by making angle theta with the x-axis, and this c is the intercept on y-axis, the positive y-axis. You can see that the c is the intercept on positive y-axis. This is the origin here. Okay. Now this is another formula, that is y equal to mx minus c. So in this you will find that the this is linear equation, so a straight line you will obtain which incline angle theta with the x-axis here, and the intercept in the negative y direction or negative y-axis, that is minus c, the intercept is there. Okay. This m is the slope of graph which is represented by the tan theta. For example, you can see that in this graph we have taken here the 2 point A and B. The coordinate of point A is x1 and y1, and the coordinate of point B is x2 and y2. So the tan theta is actually what here you can see that I have taken a triangle here ABC. The 3 points you may observe here, that is equal to ABC. You can watch it. Okay, A, B and C. The angle theta you will see here, because this angle is theta, so this is also theta, because these two are corresponding angle. So now if we'll write tan theta, the tan theta is equal to perpendicular, that means BC upon AC. And what is BC here? BC is given by y2 minus y1, and AC is given by x2 minus x1. Already you have learned about the differentiation. For the small distance, this y2 minus y1 we can write as dy, and x2 minus x1 we can write as dx. So dy upon dx equal to m, and this m is also called slope of graph and represented with the tan theta. In all cases you will find m is equal to tan theta, and c is called the intercept here. Now for the graph for parabolic equations, you can see the parabolic equation of type 1, that is y square minus 4ax. So this graph you will obtain. You can see that in this graph, this is the negative x-axis here. In this negative x-axis, both the side you will find the symmetry of the graph. This is the parabolic graph of this equation. Here you will find the second graph of the second equation, y square equal to 4ax, in which in this positive x-axis you find the symmetry of this graph both the side, that is this is the parabolic graph here. Now the next parabolic graph is x square equal to 4ay, in which you can see the y-axis, the positive y-axis, the symmetry is there of this graph you can see, and here x square equal to minus 4ay, in which negative y direction you will find the symmetry of the graph here. So these are the 4 parabolic graph. One more parabolic graph is there which you will learn in next chapter 4, when you learn the 2-dimension motion in projectile motion. This is the graph. You can see that here y-axis and the x-axis, the axes are there, that means 2 positive axes are there, and this type of parabolic graph is there. So this type of parabolic graph, the equation is given here is y equal to ax plus bx square, and it is a general equation of this type of graph. Now for the circle, the equation is x square plus y square equal to a square, or if you take a square this side, you can write this equation in this way: x square upon a square plus y square upon a square equal to 1. So this is the graph. Here you will find this is a, this is a, this is also a, and this is also a. A circle is formed in this way. Okay. Now the next equation is the equation of ellipse, that is x square upon a square plus y square upon b square equal to 1. In x square you can see that this is a here, and this is in y-axis it is b here. So this is the equation of ellipse, and this is the graph of ellipse. Okay. The last graph you will see, that is the exponential graph. Exponential graph means the equation given like this: y equal to e to the power x. So the graph you will obtain is the exponentially raised graph. This is x-axis and this is y-axis. So you find that the increasing means with the increase of value of x, the y is also increasing, but these are not in direct proportion. It is exponentially raised. Here you will find with increase of x-axis or the increase of the x coordinate, the y coordinate is decreasing here. That means y equal to e to the power minus x. So this is called the exponential raise graph, and this is exponential fall graph. So this type of graph you will see. Logarithm I will explain you whenever the class will be there. That means not in the virtual class, because in virtual class it will be not understand by you. That means not properly explained until unless you will be having the log table. So this I will explain whenever the class will be there.